Hello student, I am Dr. Vivek from Sage Group. Today we will discuss electromagnetic theory. So in this lecture, we will discuss unit-wise lecture of electromagnetic theory. So first we will start uh, some introduction about electromagnetic theory. So in this subject, basically we will discuss about what is electrostatics, what is magnetostatics, what is electromagnetic. So if any charge is in rest position, at that time which fields we are analyzing, it is known as electrostatics. Static words show that charge is stable. When charge is in motion, when charge is moving somewhere and it is in DC manner, then at that time it is comes under magnetostatics. If charge is in time varying motion, that means if any charge is moving in with respect to time, then then steady comes under electromagnetic. Some fundamental quantities that we will use in electromagnetic theory is electric field intensity. It is represented by E, and its unit is also important, that is volt per meter. Next one is electric flux density. It is represented by D, and its unit is coulomb per square meter. So these two quantity is very important in the case of electrostatics or electric field. Next one is magnetic field intensity. It is represented by H, and its unit is ampere per meter. Second one is magnetic flux density. It is represented by B. So B and H is very much important in case of when we are studying magnetic field. Next thing is in our daily life where we can see the electric magnetic field. So we all are using mobile phone. So a tower and mobile is connected with the help of electromagnetic field, and with the help of this field we can communicate between these two nodes. And in this subject, some vector and scalar topic is also very important, as we are know very well what is a scalar and vector. But in this whole subject, we will discuss many times what is scalar quantity, which quantity is scalar, which quantity is vector. So a brief review we will also see here, what is scalar and what is vector quantity. In a scalar quantity, only volume is defined, and in case of vector quantity, magnitude or in direction. We can say here only magnitude, no direction, and here magnitude plus direction is defined. Some example of vector quantity are force, velocity, acceleration, and example of scalar quantities are volume, mass, speed. These are the example of scalar quantity. Next is unit vector. It is also important. If we have given a vector, so here we have a vector that's magnitude is OA. Here we are representing this. So direction of this vector is known as unit vector, and it is represented by AOA. That means direction of OA vector. It is calculated by dividing OA vector by its magnitude. Then we can get its unit vector. That is general formula to calculate unit vector. In electromagnetic theory, where it is important when we are discussing about x-axis, y-axis, z-axis, then it is important what is the unit vector of x direction. So unit vector of x-axis is ax. What is unit vector of y-axis? Then ay is represented by unit vector of y-axis. Similarly, az represent the direction of z-axis. So when we are discussing about coordinate system, unit vector get important. Next one is position vector. Position vector actually represent position of any point in space. Suppose we have a point P, its magnitude in x direction, y-x direction and z direction given to us. If we want to represent in the form of position vector, so we will write it r. R represent its position from center, and it can be represented with the help of xi, yj and zk. So position of r will be the sum of individual unit vector as shown here. Next one is distance vector. After position, we will discuss about distance vector. So suppose we have a point P and another point is Q, and for P point we have given the magnitude of individual axes, that is x1, y1, z1. Also for Q we have given x2, y2, z2. These are the distances in x direction, y direction and z direction of this point Q. So we can represent this point by its vector. Suppose P can be represented by x1 ax, y1 ay, z1 az, and Q is represented by x2 ax, y2 ay and z2 az. These are the position vector of individual point P and Q. We are getting this is P, position vector of P, and this is Q, position of unit vector Q. Now we have to calculate PQ. PQ means distance between these two vectors. It can be represented by Q minus P. When we subtract vector Q by vector P, we will get x2 x1 ax plus y2 minus y1 ay plus z2 minus z1 az. And if we want to calculate magnitude of this vector, we will get x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. If we will divide this vector by this magnitude, we will get unit vector along PQ. That means we will get the direction of this vector. So in this way we can calculate distance vector. Next very important topic of electromagnetic theory is coordinate system. So we will discuss this coordinate system. So coordinate system generally used to specify position of a point. If in space we want to decide position of any point, then we need a coordinate system. Apart from this, if we have more complex figure and line, plane, circle, sphere, then with the help of coordinate system, we can give its exact position. Yeah, we can define that shape with the help of coordinate system exactly, properly. So to choose the coordinate system based on the problem one, there are lots of coordinate system available in this subject. Basically we will study 3 coordinate system. So it will depend which type of problem we have. According to that we will choose our coordinate system. Here, certain problem are solved by using rectangular coordinate system. It is one of the system that we will study in this uh, lecture. Some coordinate system make more sense, make it easier to describe the system. Coordinate system give you a systematic way of naming the position of space. Here, some benefits of coordinate system is discussing. We will discuss it in when we are discussing any coordinate system very clearly. So first of all, we can see here cylindrical and spiral. Three type of coordinate system we have actually. So suppose in Earth we have to find out any locations and its exact distance, angle from reference lines, reference planes. So with the help of different of coordinate system, it may be cylindrical, it may be spherical, it may be rectangular. So basically three type of coordinate system we are studying in this subject: spherical, cylindrical, and rectangular. Three type of coordinate system we will discuss in this subject. First of all, we will try to learn Cartesian system. It is also known as rectangular system. So any coordinate system, first of all, we have to know that how much variable available in this coordinate system. So if we discuss about Cartesian coordinate system, we can see that it has three variable. One is x, y, and z. So in Cartesian coordinate system, there is three variable. Next thing is what will be the range of these variables. So we can see x-axis can vary from minus infinity to plus infinity. In same way, y-axis also can vary from minus infinity to plus infinity. Same way, z-axis can vary from minus infinity to plus infinity. It is very important range. When we will solve the problem, we will use this concept that which axis may vary from which limit to which limit. So in Cartesian coordinate system, all the variable can vary from minus infinity to plus infinity. Third important thing is uh, plane. Suppose we will assume x constant. That means if x will constant, then here z is varying and y is varying, and it will make yz plane. This is z, this is y. Same way, if y will constant, then z will vary. Here z is varying and x will vary, and it will make a plane that is known as xz plane. Same way, if z will constant, then x will vary, y will vary, and it will make a plane that is known as xy plane. So here three thing is important. First thing is what is the variable, that is x, y, and z. Second thing is range. Third thing is plane. So we clearly understand what is yz plane, what is xz plane, what is xy plane. So another important thing, when we will solve the problem with the help of Cartesian coordinate system, then three quantity we have to calculate. First is differential length. First quantity we have to calculate differential length. Second quantity is differential surface. It is represented by ds. Differential length we can represent by dl. It is first quantity that we have to calculate. Third one is differential volume. It is represented by dV. Mathematically, if we calculate dl, we can calculate easily ds and dv. So we learn how we calculate dl. So to calculate dl, we have we have to move simply in the axis. So here is x axis. So first variable is x. So here we will take a small quantity that is known as dx. What is this? This is a small variable in this x axis, dx, and its direction is ax. Both are important. What is a small variable quantity in x direction, and what is its direction? Second, what is next variable? Next variable is y. If we will take a small displacement, it will be dy, and its direction will be ay. Same way, if we want to calculate differential length, yeah, a small displacement in this, it will be dz, and its direction will be az. When we will add all the differential length, that is dx ax, dy ay, dz az, we will get dl. It is differential length. Once we will get differential length, it is very easy to calculate differential volume. It is dB. It is third important quantity, as we have discussed. To calculate dV, we have to just multiply dx, dy, and dz, and we will get dV. If we want to calculate magnitude of this dl, we can use this formula. Mod of dl is equal to under root dx square plus dy square plus dz square. Two important quantity that mathematically very important for us, we can calculate with the help of dl. So we understand how we find out dl, and with the help of dl how we calculate dv. One important quantity, that is second number, is remaining. We try to understand how we will calculate this ds. So to calculate ds, mathematically it is very easy. If we have dl, dl means dx ax, dy ay, dx ax plus dy ay plus dz az. If we find out differential length, if we want to calculate ds in the direction, and here it is also important, every surface has its direction. Suppose here is a surface, its direction will be perpendicular to this surface. It is very important concept that direction of any surface is always perpendicular to this. So if we have to find out any surface in the direction of x, we can represent is it by dsx. Then we will choose direction ax, because we want to find out surface in the direction of ax. That means if we will see in this figure, so this surface will be in the direction of x. So what we will do, simply dy, we will multiply dy and dz. We will calculate surface in the direction of ax. Same way, if we want to calculate surface in the direction of ay, then we will multiply dx and dz. So here dx and dz, and its direction will be ay. Same way, if want to calculate surface in the direction of az, we will simply multiply dx and dy. Here we can see dsz, dx, dy, az. So If we know the DL, we easily calculate, if we know DL, we easily calculate DS and dV. It is very important to calculate all the differential quantities known as differential length, it is known as differential surface, it is known as differential volume. So if we know DL, that is differential volume, and we understand it very well, we can easily calculate DS and dV with the help of DL. So in any coordinate system, it is very important first of all to find out its differential length. With the help of mathematically, we will calculate exact surface, exact volume. Thank you very much for listening this video.